Hey, Principles of Engineering people. This is a quick video, just a summary of unit conversion and what we do in engineering. So you can always start with the King, Henry, drank, up, that's a D, capital D, up, delicious chocolate milk, right? This is your units. So this would be plain grams or meters or liters or any unit base or volts or amps or ohms for the questions we're doing. So couple important things to know. This is an important spot because you use the regular units for all your calculations with Ohm's law in electricity. You also use milli and kilo a lot in engineering. So basically, if you have regular units and you want to turn to milli, you move the decimal place 3 to the right. If you have regular units and you want to change it to kilo, you move the decimal place 3 to the left. There's two more places we go to in engineering too, and we don't even need to know the in-betweens. But if you go 3 more spaces, so this is an important one, this is an important one, this is an important one. The other ones we use are, so we go 1, 2, 3 more. Here's micro. So milli, micro. Look, it's the Greek letter mu. Mu is what it's called, but it looks like a U with a little tail. This is an important one. That's 1/1,000,000th. This is 1,000th, right? 10 to the negative 6 is the 1/1,000,000th, so 1 over a million. And this is 10 to the negative third. This is 10 to the 0 power, your normal unit. This is 10 to the third for the how many thousand items you have. And then if you go 3 more spaces out, you have mega, and that's capital M for millions, 10 to the 6. So we care about basically every 3 in engineering, and we always want to leave our answers in as a number between. Wait, sorry, this is unit. That's not really a prefix. This is kilo or kilo, and this is mega. You always want to leave your answer between like 1 and 999,999. So if I ever had like 5,240 grams, I wouldn't want to leave that as my answer. It's too big. It's bigger than 1,000. So if I ever have grams and I want to leave it in an appropriate answer for engineering, we just take the decimal place from where it was and move it over 3, and it's 5.24 kilograms. I always remember, since it's a big number, I'm using kilo or mega. If it's a tiny number, I'm using milli or micro. And that's just easier for me to do because it was a big number, it's 5,000, so I do kilograms. Okay, you can do it with amps. So let's say we have a tiny amount of amps. That happens a lot, like 0.000 0.052. No, why am I still using 5.2? Let me change it up. 8.2. Okay, and this is amps. So if I have that many amps, I want to turn it into something that's okay engineering-wise. Well, this is definitely not a number between 1 and 999. So I move the decimal place over until it is. Now I don't want to just move it to any of these deca, centa, hecta, I only want to hit one of these big dogs here. So if I move it over 3, and it's still not a number between 1 and 999, then I move it over 3 more. Oops, 1, 2, 3. So I moved it over 3 and 3, and it ends up here as 82 microamps. So basically, you're moving it back. You're either moving forward or back 3 or forward or back 6. If you're moving forward and back 3, you're landing on milli or kilo, depending if it's a small number or a big number. And if you're moving 6 either way, you've got a micro or a mega. So, yeah, a lot of times your answers when you do a problem, let's say I was doing ohms and I was doing a calculation, and it came out, looks kind of like a horseshoe, and it came out with a huge number of ohms, like 5, 4, 7, 1, 9, 3, 0, 0, 2. What if it came out with that many ohms? You're like, oh my gosh, that's a ton of ohms. I don't want to leave my answer this ridiculously big. I'm going to make some of these zeros, just so you know. I'm going to move in decimal place 1, 2, 3. 1, 2, 3. I finally got a number between 1 and 999. So it took me 6 moves. That is worth 54.719. And what do I put on it? It was a huge number. It's a mega ohm. Right? Okay, so you're moving at 3 or 6, either way, and you just got to remember these special ones. It works in reverse too. Sometimes you have an answer from before. Let's say I had like megavolts or something. Let's say I had a huge amount of megavolts. Let's say 3.2 megavolts. Problem with this is you can't use that in our equations for electricity. Our equations for electricity use regular amps, regular volts, regular ohms. So if you ever get a big one and you need to switch it, you basically have to know how many to move it to turn it into regular volts. Okay, how many do I have to move it to turn it into regular volts? Well, mega's way over here, and it's 1, 2, 3, 4, 5, 6 moves to get back to regular units. So if it started out as 3.2, you got 1, 2, 3, 4, 5, 6. You just got to fill in the zeros. So it's 3, 2, 0, 0, 0, 0. So it's 3,200,000 volts. Or if you had a really tiny number, let's say I had 0.0041 amps. Okay, I need to move this till it's a number between 1 and 999. So I'm going to go, oh, sorry. Well, let's do this one, then one in reverse. 1, 2, 3. So if I'm leaving my answer, it's 4.1 milliamps, because milli is 3 in the small direction. But it also works out in the other way. What if I had an answer of, I don't know, 904 milliamps, and I wanted to use it in an equation? Well, if I'm using it in an equation, I have to turn it into regular amps. That's a necessary one. That's why if you look at your worksheet, the back page is turning them all into regular ohms. Did I draw my ohms upside down? Gosh darn it. I drew an omega. Shoot. Flip-flop all these. What the heck was I thinking? It's like a horseshoe. Gosh darn it. Alright, anyway. If I want to use them in a formula, I have to turn them into regular amps. So if you see 904 milliamps, you need to move the decimal place. You're like, oh, milli starts here. I need to move it 3 that way. So I'm going to go 1, 2, 3, and it's 0.904 regular amps. Why I need to move that way is because I can only use regular amps in my formulas. I can only use regular ohms in my formulas. So you have to be cool with moving either way. It's basically, you move it this way, turn it into the weird ones for your answers, because engineers don't like to say huge numbers, so they say 5.24. We let the prefixes take care of what number it is. If we use it in our formulas, we usually have to turn them into regular volts or regular amps. Sometimes you get huge numbers and tiny numbers. But basically, as long as you know those are the big ones to hit and which way you're moving, just slide a decimal point, which is not hard. All right, good luck on this thing. Turn all your, I don't know why I drew horseshoes up that way, but if you turn all these upside down, you'll be better off for it. I wonder if I did that on the other side. Yep, I did. Jeez, oh Pete's. All right. I don't know what I was thinking. Anyway, all right, talk to you later, people.